Hello everyone. This is question number 15, October November 20, paper 1 2. In fact, this is very interesting question. First of all, we have to get some understanding of this question. In this question, we have a seawater here. Its density is greater than the fresh water, and this ice placed as floating on the seawater, and the cross-sectional area of this ice is 12 meters square. A beer of mass 400 kg is placed on it, standing on this ice. And definitely there is uh, some distance moved by this ice vertically downward like this one. So we have to calculate this distance. But the important thing is that when it is floating partially submerged means the partially submerged before this beer, and now it has some more submerging when more mass placed on it. Like if we have the side view of this ice, it's partially submerged like this one. But when we have a beer on it, like beer, maybe something like that. And then it is submerged up to this point. Initially, it was submerged up to this level. Now you have to get this distance. This is called D. This is required. So now it is very simple. When the ice is going to submerge up to this D, this is because of the beer standing on the top of this ice. So we can say in easy words that the mass of this beer must be equal to the mass of that water displaced. Definitely water displaced. And how much water displaced, that is equal to the mass of the beer. So we can say that the mass of this beer is equal to the mass of water displaced. Clear? It's like that. For example, if we put a stone inside the water bucket, the water will displace inside the bucket, and that mass of water must be equal to the mass of that stone putting inside the water. It's like that. So the mass of beer is 400 kg. The mass of the water displaced is equal to density into volume of water. Density of water is given, that is this thing, and the volume is equal to area into D, and the area is given as well. So 400,1020 into 12 into D. By solving this from the calculator, we can have 0.0326 meters, and in centimeter it is 3.26 cm, or you may write it as 3.3 centimeter. This one. So option B is correct. Again, a quick review that this ice is partially submerged inside the water. When the beer is standing at the top, it's submerged a little more inside, and you have to find this D. So we can solve this problem by the comparison of two masses, the mass of the beer and the mass of the water displaced. When we equate these two masses, then by substituting all the values, you can get that D. Thank you very much. Bye.